subject. Before we do go ahead, there are two people that will be saying a few words. Aviva, also, if you can please share with Gila that she's able to share her screen. Doron Klein, our CEO of Telfed, to tell us a few words about the organization behind these events. And Gila, after that, Heli will tell us a few words about the Weizmann Institute. And then I will introduce Heli, and then we're able to start.
Thank you, Teddy. Over to you. Toda rabah. Thank you to Teddy and to Aviva, who put together such great events. And it's wonderful to be with you all this evening. And a big thank you to the Weizmann Institute, that we can tap into the amazing knowledge that they can offer us. So a few words about Telfed. Telfed is our nickname. Tel Aviv Federation refers to the days that we were in Tel Aviv. That's from 1948. When we were established by the South African Zionist Federation to look after the 800 Machal soldiers that came to volunteer in the War of Independence. And at the end of the war, the South African Zionist Federation said, guys, come home. But a lot wanted to stay. There wasn't a Misrad HaKlita yet. So Telfed in Tel Aviv continued operating. And so we've been operating since 1948. We're no longer a part of the South African Zionist Federation. We still bear that name as part of our history. And Telfed still relates to our history when we used to be in Tel Aviv, even though today we're situated in Ra'anana. We look at our mission statement. We want to promote quality of life to the Olim that we deal with. It's today Southern Africans and Australians. We want them to feel and experience the quality of life that you can only get in Israel, being a Jew in a Jewish homeland. And we want our Olim to participate and contribute to Israeli society. We don't want our Olim to be in a bubble. We want them to participate and contribute to be part of Israeli society. And the last slide relates to the different departments in Telfed. Each square that you see is a different department with a staff member. Klita being the heart of Telfed since 1948. We deal with pre-Aliyah counseling. We meet our Olim at the airport, and post-Aliyah in touch with them on a regular basis to make sure that their Klita is going well. We have a full-time Klita advisor. Special help to lone soldiers, both while they're in the army and certainly after the army. That's been a great challenge when they enter into civilian life. We're the only organization that provides housing. We have 105 apartments, 75 in Tel Aviv and 30 in Ra'anana. And we rent out those apartments at up to 30% below market rates. So we subsidize the rentals, and 70% of the income goes to help the needy. Here we go. It goes from here to here. And that's how we're able to provide financial assistance to needy Olim, 450 needy Olim a month, together with a full-time social worker who provides counseling. The events, well, you're part of our event this evening, part of our Zoom events. We hope soon to be able to go back to face-to-face events. You can see last year we had 2,000 participants in our events, and hope that you'll continue joining Aviva and Teddy's organized events, but we hope soon to see you also face-to-face. If you're not getting our newsletter, please let Aviva know. Over 10,500 people receiving the newsletter once a month to tell you about everything that's happening with the Southern African Jewish community in Israel. Our magazine that comes out for Pesach and Rosh Hashanah. Please be part of our Facebook community, close to 4,000 people there, and our Instagram community as well. Telfed provides over 400 scholarships every year. We have scholarships called PRUS, which is where students volunteer for 3 hours a week, helping us absorb Olim. We have scholarships based on financial need. And we also have a program called SASI, South Africans Studying in Israel, where South Africans come to study before they make Aliyah. It's part of their process of checking Israel out to see if they actually want to make Aliyah. And we believe that having them study here for 3 years during their bachelor degree will help them make that decision to stay here and make Aliyah after their studies. We have 250 volunteers at Telfed. Each one of these squares that you see also has got a committee of volunteers, and we have regional volunteers helping the Olim to get information about the different regions and settle in the different regions in Israel, 24 regional committees. And our volunteers also teach English to Ethiopian Olim. That's what you see there in the picture. And the last square relates to employment. We have a full-time employment advisor helping people both pre-Aliyah and after Aliyah to get ready for the job market. We have a career counselor who helps people who need to change their career to better fit the Israeli employment fields. And we run seminars preparing people for the job market, and we have mentors. So if anyone here tonight would like to be a mentor, it means you've been successful in your field and you'd like to help Olim to get absorbed in the field that you're an expert in, please let Aviva know. And if you'd like to join us as a volunteer, please be in touch with Aviva. Aviva is in charge not only of events, but also of volunteerism at Telfed. And my closing remark is that 40% of Telfed's budget is based on donations. So if you're looking for a good organization to support that helps Southern African and Australian Olim, please remember to send your tax-deductible donation our way. You can do that via our website, and Aviva will post the address of our website in the chat. Thank you very much. Thank you for joining us. Thank you to the Weizmann Institute, to the Araba Gila. It's an honor to partner with you guys, and I wish everybody a lovely evening and a very informative one. I'm sure we're going to learn a lot. Araba.
Thank you, Doron. Thank you for that. Gila, I know that you're waiting patiently. Aviva, if you can also share with Gila that she's able to share her screen.
Okay,
Gila,
I don't have a presentation, so I'm just going to give you one. Okay, so you're stuck with me.
All good. I'm really happy. Thank you. So over to you. And all that we know about you so far is that you're from Los Angeles originally.
Okay,
you have to share
welcome.
with us as a representative of the Visitor Center to the Weizmann Institute, I understand.
Yes, so welcome. Thank you guys for taking the time to join this gathering. My name is Gila, and I am head of community relations at the Levinson Visitor Center at the Weizmann Institute of Science. Hopefully, when things get back to normal, I'll be able to host you in person. Until then, I'll give you a short and brief overview about the Institute, what we're all about, before Heli begins her talk. Weizmann Institute of Science is one of the leading multidisciplinary research institutes in the world today, that is focused on basic science, which is curiosity-driven science, science for the benefit of humanity. It began in 1934 as a very small and modest research institute established by Dr. Chaim Weizmann, leader of the Zionist movement, later on became the first president of the State of Israel, a renowned chemist with over 220 patents. And it was called the Daniel Ziv Research Institute, focused mainly on chemistry, agriculture, in order to help the growing settlement in Israel in those days. And in 1949, it was officially inaugurated as the Weizmann Institute of Science in honor of Weizmann's 75th birthday, and has growing ever since. So that small research institute today has 17 departments, which are organized in 5 faculties: mathematics and computer science, physics, chemistry, biology, and biochemistry. We also have a department of science teaching and a scientific archaeology unit. We have around 280 PIs, principal investigators. Those are professors that run the study groups that manage the labs. And we have nearly 200 staff scientists that also work independently in the labs and do their research. In addition to the scientists, we have students that study at our Feinberg Graduate School, which is our higher education institution where we train the next generation of scientists. We have around 1,200 students studying for their master's and PhD studies. We don't have undergraduate studies. It's not a university. Okay, so the students that come to Weizmann that are accepted, they are handpicked because they also receive a stipend. They are all paid a salary. Not only do they study, they actually work in the lab, so they receive a salary. So we have, the creme de la creme of the students. So they study under the umbrella of the Feinberg Graduate School. We have around 1,100 students studying for second and third degrees, and around 400 postdocs that come from over 30 countries, a lot of international students. We also have living accommodations on campus. So a lot of our students live on campus, And so do our scientists. We have neighborhoods for the scientists where they can, this way, when they're neighbors, they live next door to each other. They meet up in the playgrounds in the afternoon with their kids, or at the swimming pool, or at the tennis court. They talk about science, exchange ideas. This leads to many, many collaborations. So all of this Weizmann community environment is very productive and conducive to the science. This was part of Weizmann's vision when he established the Institute. He believed that it's not enough just to build these fabulous buildings and equip them with state-of-the-art equipment. We have to provide the scientists with inspiring surroundings, with trees and lawns, so that they can take their breaks, lunch breaks, sit outside, enjoy each other's company, talk to each other, also be close to each other whether as neighbors or the buildings. So that's a very important part of our surroundings. We also have the Davidson Institute of Science Education, our educational arm, that offers tens of programs for children, students, teachers wanting to engage anyone and everyone in science at any level, at any age. So there are a lot of programs, also online programs, programs for children that excel in science, or from underprivileged backgrounds, from the Ethiopians, Arab, you name it, Arab sector, Ethiopian sector. So we really have it's a very important part of what our scientists do and what we're all about also. So we have the scientists, we have the students, and we have the science education. And I mentioned that we're basic research, which is curiosity-driven science. So it's all about science for the benefit of humanity. We believe that if we recruit the scientists in whatever field, and we provide them with the best facilities, infrastructure, surroundings, best students, and give them the freedom to pursue their passion, they will end up doing the best possible science. And I think, it just proves for itself if we look at the results and the research, the groundbreaking research that's being done at the Institute. Now during the coronavirus outbreak, we have researches that are taking place now, and around 20 patents that were already registered. And that it takes me to the last part that I wanted to introduce, is that we, even though we're a basic research institute and it's about basic science, we have a technology transfer company, because many times the research of our scientists does eventually lead to the development of practical applications, life-saving, life-changing applications. And today, I think that the past year has shown us that without science, we're doomed. So that's also a very important, and it also goes into our budget. And the last thing you may want to know that I will offer this piece of information is that so where does the money come from? People normally ask, okay, so where's the money? How do you get the money? Our annual operating budget is around $500 million. It comes from a few sources. Less than 25% of our budget comes from the government, but we are funded by the government. A bit over 30% comes from scientific grants. Our scientists are very active and very successful in obtaining scientific grants from Europe, from the States, from Israel, and this funds the research. A bit over 30% comes from royalties of patents, which I just mentioned. And the remaining part, which is, I would say roughly around 15%, comes from friends all over the world, donors that are generous enough to help support the students, the science, the research, and make all of this amazing work possible. So I think that's pretty much in a nutshell.
Thank you so much, Gila. So without any further ado, we would like to welcome Heli. Heli, you've been sitting so patiently, so thank you for that. You need to unmute yourself. If you do need to share your screen, Aviva will sort you out, and I think that's already sorted. So just a little bit about Heli. Heli Ben Hamu is pursuing her PhD in the Department of Computer Science and Applied Mathematics under Professor Yaron Lipman supervision. Her research focuses on geometric deep learning, an exciting field with scientific for artificial intelligence. Deep learning utilizes neural networks, algorithms that mimic the most simplified model of the human brain, exceeding human performance of many tasks, including the interpretation of 2D visual images. Heli's research focuses on designing and gathering a better theoretical understanding of deep learning. Algorithms applied to graph data. Graphs are a flexible representation for many kinds of data, such as molecular, social network, scenes understanding, etc. Creating algorithms that improve computerized systems' ability to infer and extract information from such data, such as a wide span of applications to the real-life problems, such as drug design, navigation systems, and fake profile detection on social networks. In her free time, following her daughter's birth, Heli has initiated the first Coping with the Challenges of Early Motherhood and Graduate Studies workshop in cooperation with the Weizmann Institute Social Services. And she also serves as a mentor in the Mom to Mom program. Heli, over to you. Share with us this fascinating subject of artificial intelligence and a little bit about yourself, because they didn't give me much more than anything personal about you. So
you're seeing my screen now?
It's up to you. We can see your screen. Fantastic.
You can see my screen? All right. So
yes.
I'm going to talk about geometric deep learning, which is applying artificial intelligence algorithms to complex structured data. I'm going to explain during the talk what I mean by complex structured data. But before that, as you asked, I'll talk a little bit about myself. So I'm Heli. I am already 4 years here at the Weizmann. I also did my master's degree here. So we could say that I have two families. I have my own personal family, and I have this lab of Professor Yaron Lipman, and these are some of the lab members that are part of the work that I'm going to talk about today. In my undergraduate studies, I actually studied physics and electrical engineering in Ben Gurion in Beersheba. I heard that many of you are here from Israel, so you know where Beersheba is. Somewhere along the way, I realized that I was more interested in the algorithmic part, in the mathematical part. So I decided to change direction and go towards learning towards studying and researching in the field of artificial intelligence and computer science. And at the time, I had a friend who was studying here at the Weizmann, and he told me, you shouldn't like think about going anywhere else. Weizmann, it's the best place that you could go to. And I followed his advice, and as you can see, I'm already here for a little more than 4 years and counting. Actually, I'm right here at the office at the Weizmann right now because I couldn't do this talk from home. My daughter wouldn't let me skip her bedtime story, so I had to come here. And I actually realized how much I miss this place, because in the past year, I haven't really been here at the office a lot. We mostly work from home. And I really, really miss this place, the atmosphere. I mean, I come here a lot to the lawns with my daughter and to take walks, but the interaction with the people here at the department, it's really missing because we don't see each other as we used to, mostly in Zooms today. Yeah, so with that note, I think I'll just say that I hope for all of us globally that this COVID situation would be over soon. And I think that's pretty much about me. I think and let's dive into the technical part.
Go for it.
So
Or go for it.
yeah, so before we dive into what artificial intelligence is, wait a second. Did you see? Yeah, the slide changed, right? Um, so artificial intelligence is already around us in our day-to-day life more than we realize sometimes. So we have all those kind of digital assistants that support our smart homes, and we can talk to, and we can give commands, and that they understand us, or in your streaming service such as Netflix, when it suggests the matches of some TV show or some movie, how much it matches your taste in TV, or also Google Translate, when you want to translate from one language to another. All those are systems operated by, in the background, artificial intelligence algorithms. And in so much more areas, like in medical imaging, where new systems are starting to emerge, and day two, which is personalized health, that it was developed here. I mean, not specifically here, but with cooperation of one of the scientists here at the Weizmann, and systems that are able to make debate even with humans, and win a debate against humans. All those are examples of artificial intelligence that we made in our day-to-day life. And one more example that I really like is I have my Google Photos album. And sometimes I want to search for some topic, for some objects, or some I don't know, for some people in that in those albums. So here I searched for pizza, and I found all the instances of pizza in my repository of photos. They look really good. We made them by ourselves at home.
Your screen's only still showing a geometric deep learning. We don't see anything else.
You didn't see my slides changing?
No, unfortunately.
Oh, so you didn't see anything.
No.
Wait, I'm gonna stop the sharing. I'm gonna try to start all over. That's really bad.
Launch the presentation, then do sharing. Don't do sharing before, because it'll open up the presentation in another window. So what you were sharing was the basic window. So open it up first and then share the presentation, the running presentation. Try that.
You know,
all right, I'm gonna try that. I'm gonna try that. So now, yeah, but when I share my presentation, I cannot see the Zoom. Technical issues. One sec. So now you see my screen?
Now we see it, yes.
All right, so now I'm
just
gonna
need to put it onto a slideshow.
So now I'm gonna play the presentation. What are you seeing now?
We can see a picture of people, Professor Yaron Whitman, and you and
All
the
right.
baby.
So that's when I talked about my personal life. I said that I had two families.
You can see the bubble, the important one.
The what?
The most important part of the picture, the baby.
Yeah. So I said that I have two families. So one of them is my personal family, and the other is the lab members in our group. So now I'm gonna switch a slide. Tell me if you see it.
Yeah.
Yeah. All right. So if you feel that it gets stuck again, tell me, because it tends to do that, the Zoom. So that's when I talked about AI around us and how we interact with it in our day-to-day life. And I talked about the digital assistants and Netflix and Google Translate and AI in healthcare and so on. And then I moved to showing you examples from my Google Photos album
Pizza.
when I just searched for pizza, and it showed me all the images of the pizza. And then I said that we made them at home, and they were really good. And even when I query it with a more complex question, it is able to find images that match this query. So here I asked asked it to give me images of Shachar, which is my daughter, and animals. So first of all, it knows to identify Shachar. I mean, it knows to identify that it is her, even from the side, from profile, or in videos. And it also finds all sorts of animals that are with her in the images. Here she holds a snail, and that's her favorite giraffe stuffed animal. And I think an even more amazing thing to see here is that you see here that she holds a book with animals in it, and it identifies the animals in the book, and it finds this as a query to Shachar and animal. So that is also operated by an AI, artificial intelligence algorithm, that are based on the recognition of images, and we're gonna talk a little bit about that later. So artificial intelligence, what is it? How I mean, how do we define it? Maybe. So I'm gonna give you like the dictionary definition, and then I'm gonna try to break it into parts and to tell you how it is done today and what is the technology that we use. So artificial, you're saying the slide's changing, right? You're saying, yeah, okay. So artificial intelligence is, I mean, the goal of artificial intelligence is to design algorithms or computer programs that are able to perform tasks and solve problems that usually require human intelligence. So in a way, it is an artificial intelligence. And the way that we do it today is by designing algorithms that try to mimic the most simplified model of the human brain. So the human brain, I'm not a neurobiologist, but the human brain in a very, very low level is composed of small computational units that are called neurons, and they are connected between them in a very, very complex network. And the neurons could be thought of as small computational units that share information one from another in a very complex way. And just to get an intuition of how many we have in our brain, is that an average human has 100 billion neurons in his brain. And what we do in artificial intelligence algorithms is we design artificial neural networks where we have in our algorithm digital neurons, not physical ones like we have in the brain. And what our algorithms have to figure out is how to connect between those neurons in order to be able to perform a certain task that we assign to it. And as you can see here, and I mean, in contrast to how the brain is connected where I said that it is such a complex network, and I don't know, we might have connections forward and backward and all sorts of connections. And here we have kind of a feed forward way. We have layers, and each layer is connected to the next one. So it is a more simplified model of our brain, but it is able to do amazing things. So artificial neural networks are mainly composed of layers, and the things that we have to figure out in order for the algorithm to learn something is the connections between those layers, between those neurons. And we call this process of teaching the algorithm to do something a process of training. So how do we do it? Just like humans do, we're our best inspiration. We do it by trial and error and learning through examples. What happens in the training process of an artificial neural network is that we have a lot of data, labeled data, and we show it to our algorithm, and we show the answer to to this query. Maybe let's talk about a specific task. Let's say that we want to classify images. Say we have a bunch of images of cats and dogs, and we want our algorithm to be able to say whether a given input image is an image of a dog or an image of a cat. So in the process of training, what we're going to do is we're going to show it images of dogs and cats and tell it also the true answer to each of the images that we show it. And in that process, we tweak the parameters, the connections between the neurons in a way that pushes it towards giving the right answer to each example. All right, and in this process of learning, the algorithm becomes, you could say, smarter or better at doing this task. So actually, the idea of artificial intelligence has been in the world for a very long time now. And one might ask, why now? Why this revolution is happening nowadays? It's already started almost 10 years ago, actually, but it is a really bubbling field. And it is mainly due to two advancements that happened in the past years. And the first one is that we have more powerful computers facilitating these very heavy algorithms. So as I said, human brains has 100 billion neurons. In our artificial networks, we don't have 100 billions, but we almost get there nowadays. And the second thing is that the internet and data revolution has happened. Actually, I mean, just I took the snippet from the internet, what happens every minute online. So you can see how much data, how much new data is created every minute. And the pace is only getting faster. So with that much data, the algorithms are being able to be, in a way, just like us humans, which have the whole world just spread in front of us. I mean, so that's the two things that, the way I see it, that facilitates this change in the world. So now I'm going to focus a little on how neural networks are applied to images. So today, those artificial neural networks are able to outperform humans in tasks like classification. Here we have an image of a woman. Here it's classed as a person. And the network gets it as an input. It has to give the right class. So that's a classification task. In detection, here on the left, we see a dog and a cat, and our algorithm detects the dog and puts a box around it and says that it is a dog, and it is sure about 90% that it is actually a dog, and a yellow box around the cat and says that it is 93% sure that it is a cat. So that's detection. And also segmentation. That's the image on the right, where we have a scene and we have to break it into segments with, it's kind of a classification, but over the whole image. So we see that we have a moving car and we have a stationary road, and so on and so forth. So algorithms today, based on deep learning, are actually outperforming humans on those tasks on images, but images are just not enough. So images are a two-dimensional projection of the 3D world that we live in, right? So I want to give you an example. Here you see two yellow balls, two yellow bubbles, and you see it on your two-dimensional screen, right? So to all of you, agree with me, it seems that the right one is smaller than the left one. But is it smaller? I mean, maybe the right one is just a little further away, so it seems smaller. And that's why we need to work with more complex data in order to gain an understanding of the world that is better than just from images. Because, I mean, us as humans, we see in 3 dimensions, not just in 2. So we want more, and I actually broke this list into 2 pieces. The first one is applications to three-dimensional data. And the second one is actually even a more abstract, more complex form of data that we call graphs. Where in graphs, I think that the simplest example is through social networks. So imagine that we have a social networks and we have users in the social networks, and those users are playing the role of nodes of the graph, and connections between them represent the friendships between them. So say I am a user of Facebook and I am friends with Teddy, then we would be connected on the graph. All right, we would be two nodes on the graph and we would be connected on that graph. So that's really a simple example of what graphs are, but they are very flexible representation of data that allow us to represent even more complex types of data. So in our lab, we focus on those two main disciplines, where the type of data that we deal with, the complex data, is called irregular data. So the first one is three-dimensional representation, as I said, and here on the right, you see results of a project that was done in our lab. I was not part of it, but I thought it would be really cool to show it, where they reconstruct the three-dimensional representation of this skull shown on those images from only from images. So the algorithm gets as an input only those 4 images, and it is able to reconstruct the three-dimensional structure of the skull. All right, so you don't have like a 360 view of the skull. You just have a couple of images, and you're able to reconstruct the whole structure of the three-dimensional object. And that's really cool. And my research actually focuses on the more abstract side of irregular data. It would be, we're getting to the technical part, so be strong. Graph representation. So as I said, examples of graph representations are social networks, where here we have friends and users of a social network, and they are connected if they're friends, or also molecules, where each node in the graph are atoms, and they are connected if there is a chemical bond between them. So dealing with the irregular data has some challenges that do not appear when we deal with images. So here on the right, we see an image of a cat, right? And wait, I'm gonna try to, maybe I'll have a pointer so I could, how come I don't have one? Okay, I'm just gonna let it go. So on the right, we see an image of a cat, and in the first image, it is in the right hand side of the picture, and on the right, that's really confusing. On the right image, it is translated to the left, but it is still a cat, right? Either way, whether it is on the right of the image or on the left of the image. So I want you to recall that I told you that artificial neural networks are designed in layers, where we have following layers that have connections between them. But just throwing lots of neurons on those layers would not give us the things that would not achieve the goal that we want. So what we do when we design those layers is we incorporate the inherent symmetries of the data that we work with. So for images, for instance, our layers are invariant to translation. All right. So when a layer gets, and when a neural network gets an image of a cat that is on the right-hand side of the image and gets a cat that is on the left-hand side of the image, it would still classify it as a cat. All right. So we incorporate the symmetries into the choice of the architecture of the layers of the neural network. But with graphs, things are a little more complex. So look at the image here on the left. So we have like a bunch of nodes and they're connected one to another, but we don't have a sense of what is up, what is down, what is right, what is left. So translation does not seem like a good symmetry to work with here. So we have to find what are the symmetries that are applied to this type of data. So in order to see that, let's look at a very simple graph. We have here a graph with 4 nodes. One of them is labeled green and the other are labeled blue, and the black lines connecting them represent the connections in the graph. All right, and I could represent this graph in a matrix. All right, this matrix is a 4x4 matrix as the number of the nodes that I have. The diagonal of this matrix represents the nodes themselves, and the off-diagonal elements represent the connections between each node. So we see that none of the blue nodes are connected one to another. So when we have an entry that represents a connection between a blue node and another, we see that it is colored in gray, and the green node is connected to all the blue nodes. So each entry that represents a connection between the green and the blue node is colored in black. So it means that they're connected. And that's actually how we represent graph in the computer, in a matrix, but not in colors, but with numbers. But that's simplified representation. So now I'm going to ask, what are the symmetries of this representation? What kind of transformations I could apply to this representation that would still be the same graph? Just like when I translated the cat, it was still a cat. So for graphs, the symmetries are permutation. All right, so say that I have the nodes in my graph ordered in a certain order to begin with, and then I shuffle the order of the nodes, but the connections remain the same. I mean, the green node is still connected to all the 3 blue nodes, and none of the blue nodes is connected to one another. So I just shuffled the ordering of the nodes, but the graph is still the same graph. So the question now is, how do we incorporate those symmetries into the architecture that we use? So in a very, very, very simplified way, we can think about it that, you remember when I said about images, is that we don't have a notion of what is up, what is down, what is right, what is left. So here on graphs, we have a notion of who are my neighbors, who am I connected to? And that leads us to the message passing neural networks, which pass messages across graphs. All right, so now we have an example of a graph here, right? So humans are the nodes of the graph, and some of them are connected, some of them are not. And the very basic, simple layer in a neural network that operates on graphs just passes messages to the neighbors of each node. All right, so now I have this man in the middle, and he has a message that he wants to pass on to his neighbors on the graph, and it would pass it to his neighbors. And what the neural network has to figure out is how to weigh those messages that came from one neighbor or another. So we do have to learn things here, but that's about it. And I mean, our work on that field is very theoretical, so I'm really sorry that maybe it's not very clear. But what we did in one of our works is that we characterized all the operations that are permutation equivariant. Namely, just as translation in images is the basic operation that is invariant to the symmetries in images, on graphs, we were able to characterize all those operations. And in another work that we did, we also dealt with limitations of message passing neural networks that, for example, are not able to distinguish between these 2 graphs. So here we have clearly, all of you see that these are 2 different graphs, right? One of them is one connected component, and the second one is 2 components of triangles. So they're not the same, but message passing algorithms would say that they are the same due to some limitations in the expressiveness of that. And in another work that we did, we developed an architecture that overcomes this expressive power and is able to identify those graphs as different. So, I mean, let me try to give you a little motivation to learning graphs because it is really abstract. But in social networks where we have today an epidemic of fake profiles and fake information that is spread all over the networks, such algorithms of graph learning are a core part of identifying the sources and the sources of such fake profiles. Also, recently I've seen that Google Maps has updated their algorithms to use graph neural networks in their navigation systems. So that's a really nice thing. So it is a really important and very has applications on many fields. And for dessert, I've recently done a work on something a little off topic, a little not on complex data. I came back to images, but it is a really cool stuff. So an issue with the neural networks is that we have to deal with security now that they are part of many parts of our life. We need to have those as secured algorithms, secured systems that do not fail on cases where a human would not fail. And one, I think the most important example where we want those systems to be robust is autonomous driving, for example. So one vulnerability of neural networks is that it is susceptible to adversarial examples. And here what we see is an image of a dog, wherein the network gets these images as an input, it classifies it correctly as a dog. But then we just add this little noise, very small change in the image, right? The result is here on the right. The image on the right is the original image with this added noise. And it messes up the classification of the network. The algorithm suddenly thinks that this is an ostrich. And that's one of the vulnerabilities of neural networks that people are really dealing with it and thinking how to solve this problem. Because what actually happens is that the neural networks are, in a way, tend to do well on the distribution of the data that it had seen. But when you add a little noise that is out of the distribution of data that it had seen, it then gets wrong. So in a recent work that we have just submitted, we have developed one of the methods people are developing all the time, a method to improve the robustness of neural networks. And I want to show you some examples of images. So the first row is the original images with their original labels. So here we have a truck, a horse, a frog, an automobile, a truck, and an airplane. And in the row below, we see adversarial examples that were found under one of the attacks, one of the best attacks that exist today to fool neural networks. So here what we see is the image of the attack and below the class that our algorithm, that our robust neural network had classified. So unlike the image that we had seen before, where the change in the adversarial example was really small and there was no semantic change for us, I'm going to go back to it. For us as humans, it would still be a dog. I mean, nothing has changed. Here we see that in our robust model, we were able to achieve changes that are semantic. I mean, you can look on the right on the airplane that suddenly turns into a deer, So you can see that it grows horns, just like a deer. So you would understand why the algorithm would maybe classify it as a deer, but and also for us as humans, it is no longer an airplane. Or I think a very nice one is the horse that changes into a dog. So it kind of adds an eye right on the bottom. So it's like a dog leaning to the left. Or on the image on the left, where the truck turns into a horse, just like a head of a horse grows here on the left. So there are really promising directions there, and we are very, I mean, it is a very important problem to solve, as our lives rely more and more on those artificial intelligence systems. So we want them to be robust and secure. And I think that would be it. I'm really excited to be a part of this field. It is, it really feels like being a part of a change in the world, and I really hope to turn it into a good direction. So
Thank you,
thank you all
Heli,
for
so
listening.
much. So everybody's welcome to unmute themselves if they wish and to ask a personal question. What about you, Errol?
Me? Why me? Okay. This is quite, thank you very much. It's very interesting. Quite fascinating how the slight noise can distort the actual AI formulation of the image in its, because as far as I understand, it generates a part, it recreates parts of it. That's how I'm sure it works with, especially in the medical fraternity, where you have an image and there are parts missing, and the AI will fill in those parts like you did with the skull. You have the man will actually generate automatically set extra parts to give you that 3D look. And there's actually a freebie, quite interesting enough, on a my son was showing me, where you take a photograph of yourself online and it actually gives you a digital image of yourself, and a 3D image. You're smiling and walking around. It's actually quite cute. Not that accurate though. Mm-hmm. It's pretty, you have to play with it and tweak it, the picture a little bit, but it's pretty decent, I think, for a sort of mess about type of thing. But this is actually, your area is very, very, very controversial in many countries, I'm sure, because you got like China, where they're using this very nefariously. And our question is, how accurate are they in the Chinese field? Because I know they do a lot of monitoring. They have this point system, and you go to the talk to the wrong people, everything. And they're using facial recognition. And now with masks, this is a real challenge for this type of AI technology, because all you got to go on is the eyes and maybe ears. Mm-hmm. They must be struggling like crazy there, or have they got their technology to a fine level that they can actually identify the person quite accurately? Have you got anything to say about it? Because this is a fascinating area. Because unfortunately, with every good there comes the bad, and this is what people fear quite significantly.
You're you're definitely right. But I think that, yeah, with every good comes the bad. But as I finished my talk, I really hope to contribute to the good part.
No doubt. I understand it. But I'm just saying that this area is quite. You people are pretty advanced. I work for a company an online gaming company, and we have purchased an AI company that analyzes all gambling done through our sites, millions of transactions a day, and to isolate people with gambling addictions and things like that. And it's quite robust, and does a pretty good job. So I understand this area. I'm not an engineer, but I do understand quite a lot what goes on. And it's fascinating, and so it does have very many practical good applications. As I said, in my company, it's a fantastic application. If you can isolate somebody with a problem, you can help them. You've got a chance of saving them from themselves and providing them with the possibility of curing themselves or dealing with their problems. So there are many practical positive applications to this. Absolutely, absolutely. So I just sort of brought up, because there are a lot of things that go through my mind while I'm watching your presentation. Just sort of throwing it out there.
Thank you.
So I'm happy I triggered you.
I see that
Yeah.
Nikki has put up her hand. Nikki, would you like to ask us a question? Welcome.
Hi, yes, I hear me. Thank you. I second Errol's opinion that it was absolutely fascinating. And I think we should certainly have more lectures of this type. What I wanted to ask was a little bit more of a personal question, and that is, in light of everything that you know as an individual, what are your feelings on having a social profile in social media? Is it something on a personal level you advise against, or you still trust the way that our data is managed and distributed and manipulated? Yeah, that's what I'm curious about.
So I think that I've always been a little old-fashioned about social media. I've never shared a lot on that. I think that today there are really good ways to gather that data and still maintain the privacy of the people that the data was gathered from. People are working on that. There are fields concentrating specifically on that. I'm not sure about the actual term that it's called, but in a way, I'm not sure exactly what it's called, but it's called it's like anonymizing the data that you're gathering. So it's not specifically like if Facebook, for example, are now gathering information from their users, they don't gather specifically the information and it is connected to you. They maybe do an analysis on a large scale, like on a whole, like on a network, and not specifically on you as Nikki. There are also applications to personalized profiles, just like when they suggest they post ads that are personalized to you, to your. There was just recently a very large issue around the WhatsApp sharing their information with Facebook towards personalizing or advertisements. So, I mean, I'm not really familiar with what really happens in there because I'm not there. But I do know that there are efforts on anonymizing our data, but also there is a lot of very, very long agreements that we sign up for without reading, and we don't really know what we are signing up for. So I would be a little careful about that. That's my personal view on social media.
Heli, I've got a question about our telephones. You know that whenever you have your telephone on next to you and you speak about some holiday you want to go on in the Caribbean, and 2 minutes later, there's some adverts pushing at you about holidays in the Caribbean. How can this be possible? Is it true? Is artificial intelligence listening to us? And is there some way to protect ourselves, maybe?
So I don't know, but I mean, I don't like you saying that it is the artificial intelligence that is listening to us. The artificial intelligence is not the one that is listening to us. It's people operating artificial intelligence that maybe are listening to us.
Can I jump in? Teddy, if you can prove that, you'll change the world. Nobody can prove it. That they're listening to when you actually aren't on the phone. They can't prove it. Nobody can prove it.
No, of course, but I mean.
But they probably do. Who knows?
The thing that bothered me was that he said that artificial intelligence is listening to us. So no, artificial intelligence does not have the ability to do it on its own. It is humans operating those algorithms. At the end,
they collect the data, and what they do with the data is something else. The data is collected, yes, no doubt,
yeah. Because I think one of the things that is frightening people is that artificial intelligence, I don't know, will take over humans, and I don't know, but from where I am now and the knowledge that I have about the field, we're not even close to that. I mean, at the end, it is humans behind it, and like every technology that has been developed by humans, which is powerful, the good comes with the bad, just like Carol said. I mean, and we're making right effort on getting the good out of it, and there are also people here at the Weizmann that are researching security and privacy, just the things that you people have asked about and mentioned. It is a really important thing to deal with, and to somehow regulate the way that we use this great power. That's
agreed.
Yeah.
Would anybody else like to ask a question in person or via the chat?
Yeah, I have a question if you don't mind.
Certainly. You wanted to ask it just as we started and you got cut off. I know that. So here's the turn now.
So isn't there a risk that this artificial intelligence could be potentially manipulated by creating false noise so that actually the algorithm leads it down a different track? Because if the algorithm is trying to calculate through the noise to give you an accurate representation, what's stopping developing fake noise so that the algorithm is fooled?
I'm not sure what you mean when you say fake noise.
Isn't the algorithm trying to see and to differentiate different things? So, for example, it's trying to research or look through data, right? And it's applying the process of looking at the data and analyzing it to come up with the end search of what you wanted in the first place. Is there not a possibility that from a security perspective, somebody could intersperse or put in a different layer that distorts what the algorithm is actually looking for, ultimately actually look for something else? Doesn't this potentially pose security issues, considering we rely so much on this? Can it not be faked or distorted or corrupted?
So I think the example that I gave is kind of what you're asking. I'm not sure about someone adding a layer or something like that, but the example with the image of the dog that was added to only a very small noise that was not visible to us as humans, and then the algorithm actually gave a wrong answer, right? To that is one of the vulnerabilities that we are aware of, and we know that those systems have. I mean, the whole community is trying to find ways to overcome these weaknesses of those algorithms. I mean, when let me just add one more thing. I mean, when you use AI for, I don't know, for recommendations on Netflix, if someone added noise to your recommendation system, it would not be that bad. But again, I think one of the most crucial example is autonomous driving, where I mean, when such things could be fatal, and that's something that before we make those worldwide changes, we have to be sure that they're secure enough. I mean,
yes, yeah. I guess with self-driving vehicles, you wouldn't want the vehicle to become confused about something. The instructions, red means this, blue means that, you know, whatever.
Yeah.
So I guess so. So I think that everybody's asked their question, unless somebody else still wants to ask something. I wanted to thank also Adi from the Weizmann Institute for joining us and helping us put this event together this evening. Thank you so much as well. And say good evening to you all. And just to remind you that we do have some upcoming events. Telford's having a blood drive on the 5th of March. If you're able and interested to donate your blood, please check on the Telford website and you'll be able to find information. And on the 9th of March, we'll be having our election panel discussion with moderator past MK Dov Lipman. So please join us for that with all the major political parties who will be sharing their manifestos. Once again, thank you all for joining us and have a great evening.
Thank you, Heli. It was fascinating.
Thank you very much.
Thank you,
Thank you very
guys.
much.
Bye-bye.
Thank you.
Bye-bye.
Good evening.
Thank you all. Thank you so much for joining.